The secret of Sudoku is to identify pairs. My annotation method, which I explained in the video Become a Sudoku Expert in 10 minutes, is, in my opinion, an excellent way to identify pairs. However, there are some pairs which will not be identified by that method, and to identify these pairs, which are called hidden pairs, we have to use a much more exhaustive technique. I'm going to try and show you that technique now, and I guarantee that if you can understand it, your Sudoku technique will be immensely enhanced. When you come to those types of problem where you put in all the easy answers and you get completely stuck, at that moment you need to use the technique that I'm about to explain to you here. Good luck. Okay, so here's a puzzle where we've reached the stall point, as I call it, where it no longer becomes simple to enter numbers or relationships between numbers. In this particular case it's happened a little earlier than usual, but that's all to the good. So at that point what we need to do is work through each row and each column until we find a hidden pair. And I would suggest you may want to start with columns or rows with more numbers. For example, this row has 5 numbers, this row has 4. You may want to start with those ones, or this one here has, let's see, 1, 2, 3, 4, 5, 6 numbers effectively already filled in. When you'll find that these rows with just one are a little bit harder, and you'll understand the technique I'm going to use and why that is in just a moment. So rather than go through each row and column, which would be very tedious, I'm just going to show you how to do it in this particular row, because in this row there is a hidden pair. So to find out the missing pair, as with most things, we have to start out with what we know. And what we know is that there is an 8 here, a 2 and a 9 and a 3 in this row. That leaves 1, 4, 5, 6, 7. I'm going to write these up here. 1, 4, 5, 6, 7. And I'll be using this area above the puzzle as a work area. So to discover the hidden pair, what we have to do is evaluate each square that is unknown in this row to find out which of the unknown numbers it cannot be. Which of the unknown numbers it cannot be. And the way we look at that is first of all within the same box as the unknown square, and then in the associated column. If it were a column that we were evaluating, we would be looking in the associated row. So we're going to start with this first number here. In the associated box there is a 5, and there are none of these numbers in the associated column. So we can write 5 here. In the next unknown square, similarly, obviously there's a 5 in the box, and there are none of the missing numbers in the associated column. So again we can write 5. For the third unknown number, we have a 1 and a 4 in the same box, and in the same associated column we also have a 4 and we have a 7. So we can write 1, 4, 7. For this number here, in the same box we have a 4 and a 6. In the associated column we already have a 4, of course, and we have a 5. So we can write 4, 5, 6. 4, 5, 6. And the final unknown number, again in the same box we have a 4 and a 6. In the associated column we have a 1 and a 7. Now notice the 7 can be either in this box or in this box. Whichever box it is in, it will effectively stop there being a 7 in this square. So we can write 1, 4, 6, 7. 1, 4, 6, 7. So now we have to evaluate the numbers that we've put down for the hidden pair. Now, since we have 5 unknown squares, we're going to be looking for either 2 squares with 3 of the same numbers, or 3 squares with 2 of the same numbers. And if we have that, we have a hidden pair. And as you've probably already seen, in this square here we have 3 numbers 1, 4, 7, and in this number here, this square here, we also have 1, 4, 7. So that means that there must be a hidden pair between this square and this square. What is the hidden pair? The hidden pair is the missing number from the 3 that are common. So we have 1, 4, 7, 1, 4, 7. That leaves 5 and 6. So we have a hidden pair of 5 and 6 here. So I'm going to erase the 5. We knew it was a 5 in one or the other. I'm going to replace that with a 6. So what follows from that? Well, if we know that this is 5 and 6, 5 or 6, and this is 6 or 5, well, clearly it can't be a 6, so it must be a 5. If it must be a 5, then this square must also be a 6. And if that square is a 6, that leaves a 5 and an 8. The 5 cannot be here, it must be here, and the 8 must be here. So you can see how much that helps us to decode this puzzle. Some of the more observant of you may also have noticed that we could already have put in the 5 in this square, because in fact we already knew 4 of the unknown numbers, 1, 4, 6, 7. That only leaves 5, so just from the observation on that square alone we could have put in a 5, but not necessarily a 6. Now I'd like to show you more precisely or more scientifically that technique that we just used for that row to identify the hidden pair. This is an interesting spreadsheet. It's effectively a 3-dimensional spreadsheet, and I'm trying to show you what you're looking for with this method of analysis. So this column here indicates the number of squares that you do not know in the row or column. So in the example we looked at just now, it was 5. Well, 5 squares to fill in. And what we actually saw was that there were 3 known unknown numbers, both the same, in 2 squares. They were 1, 4, 7 if you remember. So 1, 4, 7, 3 unknown numbers appeared in 2 squares. That allowed us to identify a hidden pair. It could have been the other way around. It could have been perhaps 1, 4, 1, 4 and 1, 4, 2 numbers, in 3 squares. That would also have identified a hidden pair. So those are the blank squares. They'll help you to identify hidden pairs. Now the grey pairs, where it's in grey, that indicates where you can work out definitively what the number is. So if you have 4 known unknown numbers in one square, then for which there are 5 unknowns, then clearly you know what is in that square. And similarly, if you have the same unknown number, just one unknown number, across 4 squares, then that only leaves 1 square, and you know that that number must be in that 5th unknown square. So this takes that principle for all the combinations. So for example, if you had 7 known squares, you'd be looking for 5 known unknown numbers occurring on 2 squares, or 4 known unknown numbers appearing across 3 squares, and so on. If you have any of these combinations, then you'll be able to identify a hidden pair. Wow, Did you understand that? If you understood that, you can give yourself a very big pat on the back, because that was very, very hard for me to explain, and I do hope that you understood it. As I said before, I guarantee that if that method was understandable to you, when you have very, very difficult Sudoku puzzles, you will be able to solve them. Now, just one thing I should say is that I've talked all the time about hidden pairs, and you may have identified an inconsistency, because when we have larger numbers of unknown squares, for example 6 or 7, there is the possibility of hidden trios, or even theoretically a hidden quartet. Now personally, I've never come across a hidden quartet, and it may not even be that much use if you identify it, but certainly hidden trios do come up every now and again. So you do need to be on the lookout for hidden trios occasionally, and they can help you solve puzzles just like hidden pairs. So there you are. If you can spot hidden pairs in this way, your Sudoku technique will be unparalleled, and you will have much, much more fun with those harder puzzles. Good luck.